Hello everyone, this is Sir Don and we are now going to find the sum and difference of dissimilar rational algebraic expressions. So these are rational algebraic expressions with different denominators. This lesson in finding the sum and difference of dissimilar rational algebraic expressions, students are expected to find the sum and difference of dissimilar algebraic or rational algebraic expressions. Okay, so in adding or subtracting dissimilar rational algebraic expressions, you always have to get the least common denominator or the LCD of the fractions and use this to rewrite them as similar fractions. So you have to go back with finding the least common denominator. So there are different methods in finding the least common denominators, but I will be teaching you one method only. So for you to understand the process, let's have this first example. So we're going to find the sum of 5 over 18a raised to 4b and 2 over 27a raised to 3b squared c. So our solution, and we have 5 over 18a raised to 4b plus 2 all over 27a raised to 3b squared c. So the first thing that we're going to do is we're going to find the least common denominator. What we're going to do here is that we're going to refer to the denominator. So in our first given, we have 18. We have 18a raised to 4b. This is the first denominator, and we have 27a raised to 3b squared c. This is our second denominator. The first thing we're going to do here for the first denominator is we're going to factor this out using prime factors. We call this one as prime factorization. Okay, the process that I'm using here is prime factorization. So we have 18, that is equivalent to 2 times 3 times 3 times a times a times a times b times a. So since we have 4 a's here, we can also have here a times b. That is also correct. Anyway, multiplication is commutative. Then we have 27a raised to 3b squared c. So this is in prime factorization form. We have 3 times 3 times 3 times a times a times a times b times b times c. Okay, then after that, we're going to get common factors. We have to encircle common factors. We have 3, another, this one, and b. So the rest, these are non-common factors. Okay, then after that, to find the LCD, we're going to multiply those non-common factors and then the common factors. We have here 2 times 3. 3 is here. This is considered as 1, so this is a common factor. This is another common factor. This is another common factor. Another common factor, another common factor, and this one, another common factor, then another common factor, then, and this one is not a common factor, there's no pair for this one. So we have here b times b times c. Multiplying this, we have 2 times 3 times 3 times 3. That is equivalent to 54. That is 27 times 2. That is 54. Then a raised to 4, 1, 2, 3, 4, and we have b squared, this one, b, and we have here c. Then after that, our least common denominator is 54a raised to 4b squared c. So we are going to rewrite this one in such a way that the denominator is 54a raised to 4b squared c. To do that, you are going to divide this one by this. So 54a raised to our second example, we're going to subtract t plus 3 all over t squared minus 6x plus 9 and 8t minus 24 all over t squared minus 9. So this example gives a denominator as well as the numerator which can be factored out using the different factoring techniques. So our solution is t plus 3 all over t squared minus 6x plus 9 minus 8t minus 24 all over t squared minus 9. So find the LCD. We're going to refer to the denominators. Okay, so we have here the first denominator, that is t squared minus 6x plus 9. So we're going to factor this out. The factored form of this is t minus 3 times t minus 3. T squared minus 9, this is our second denominator. The factored form of that is t minus 3 times t plus 3. This is the sum and difference of a binomial. The factored form of a difference of two squares. Okay, as you can see, this one is a common factor. So this is counted as 1. So the other factors are, so we have here this one. This is counted as 1. So we have here t minus 3. Then t minus 3 here. T minus 3. Then t plus 3. That is t plus 3. So the LCD is t minus 3 times the quantity of t minus 3 times the quantity of t plus 3. For second step, we're going to use the LCD to make the rational algebraic expressions similar. So to do that, copy the denominator. This one will be copied. This LCD is copied. Then we're going to divide this one by this one. So the factor form of this one is this one. So we're just going to go directly with this. That is t minus 3 times t plus 3 divided by this one. The remaining value will be t plus 3. And t plus 3 will be multiplied to t plus 3. So this one is divided to this one. The quotient will be multiplied to this one. And the product is t plus 3 times the quantity of t plus 3. Minus the denominator here, or the LCD, divided by this one, t minus 3 times the quantity of t plus 3, multiplied to this one. So the answer here, this one is divided to this one. So the answer is t minus 3. Multiplied to this one, then the product is this one. Quantity of a. So we're not yet done. What we're going to do now is we're going to simplify. When we say simplify, we're going to perform the given operation. So this one will be multiplied using a, we call this one as the FOIL method. Squaring this one, it is equal to t squared plus 6t plus 9 minus the product of this is 8t squared minus 48t plus 72 all over this one. So here I did not simplify this one because I can use this one in canceling the dividing the numerator by the denominator if there are, to reduce this one to lowest term. Then subtracting this one, we have negative 8t squared plus 48t minus 72. So we know that in subtracting polynomials, the sign of the subtrahend changes. So we have negative 80 squared plus 48t minus 72. Okay, so after this, we're going to combine terms that are common. So we have here negative 7t squared plus 54t plus 63 all over the denominator, which is t now, the quantity of t minus 3 times the quantity of t minus 3 times the quantity of t plus 3. So since this one, the numerator is not factorable already, so we can copy this one. This is already a prime number. And since we cannot cancel any term, so we can simplify this, and that is equivalent to t cubed minus 3t squared minus 9t plus 27. If you prefer this one, wherein the denominator is in factored form, that is already accepted, that's also accepted. Or if you have this one, this is also accepted. Example problem number 3. We have to find the sum of 2x all over x squared plus 4x plus 3 and 3x squared minus 6 all over x squared plus 5x plus 6. Again, you have to go back with factoring polynomials. We have now in this solution. So that's 2x all over x squared plus 4x plus 3 plus 3x squared minus 6 all over x squared plus 5x plus 6. The first step that we're going to do, we're going to find the LCD and we're going to refer to the denominators. So we have here, the first denominator is x squared plus 4x plus 3. The factored form of that is x plus 3 times the quantity of x plus 1. And we have x squared plus 5x plus 6. The factored form of that is x plus 3 times the quantity of x plus 2. So we see here that the common factor is x plus 3. So this is counted as 1. So that is x plus 3 times x plus 1 comes from here. And then the other one is x plus 2. The other one here. So we have here the least common denominator. Our second step is that we are going to use the LCD to make the rational algebraic expressions similar. So we have here the LCD. Then this one will be divided by this one. So the remaining value is x plus 2. X plus 2 is multiplied to 2x, and that is 2x times x plus 2. This one, the denominator, will be divided by x plus 3 times the quantity of x plus 2. And then the answer is x plus 3, x plus 2, x plus 1. Multiplied to this one. So the answer here is 3x squared minus 6 times the quantity of x plus 1. I mean 3x only. 3x minus 6 times the quantity of x plus 1. Okay, so then after that, we're just going to simplify. That is 2x times the quantity of x plus 2 plus 3x minus 6 times the quantity of x plus 1 all over x plus 3 times the quantity of x plus 1 times the quantity of x plus 2. Then distributive property, that will become 2x squared plus 4x plus 3x squared minus 3x minus 6. So this comes from the FOIL method applied to these two binomials. All over x plus 3 times the quantity of x plus 1 times quantity of x plus 2. Combining terms that are common, so we have here 2x squared plus 4x plus 3x squared minus 3x minus 6. So we have here common, these two are common, 4x and 3x are common, then 6 is alone, so there is no common constant term for this. So we're just going to add 2x squared plus 3x squared, that is 5x, 4x minus 3x, that is x, and we have here negative 6. So since the numerator is not factorable, so we're just going to copy this one and then simplify the denominator. So either of the two here are accepted as or is accepted as correct. So I hope that you learned something about this. I think this is one of the most difficult lessons in operations of on rational algebraic expression. So you have to go back with finding the LCD. Then that LCD will be divided to the denominator of the first given fraction or the fractions or denominators of the fractions. Then multiply it to the numerator to make the two or more rational algebraic expressions similar. So if they're already similar, then you can simply add or subtract the given rational algebraic expressions. Thank you very much, and I hope that you learned something for today.